Welcome to today's webinar entitled Charging Forward, Instituting eMobility on Your Campus. My name is Billy Zadig, Manager Special Projects for APA. Just a couple of housekeeping items before we get started. The webinar recording will be posted to the APA website later this afternoon. Please visit the APA website for archived webinars that are available to everyone for continuing education credits recognized by local, state, and federal professional entities. Professional continuing education and AIA-CLU certificates are being offered for today's program. If you are an AIA professional, please send an email to me at Billie, B-I-L-L-I-E, @apa.org, along with your AIA membership number if you've not done so in the past. Those who indicated they wanted a certificate during registration and meet the requirements will receive certificates later this afternoon. All attendees are in listen-only mode. Please type your questions in the chat box and they will be answered in the order they are received. If we run out of time and we still have questions, responses will be sent directly to the person asking the question by one of our presenters. If you're just calling in, make sure you send me an email at billie@apa.org so I can send you a certificate if you would like one. The system only recognizes you if you log in. If you click on the handout button, you can download the brochure that will be mentioned in today's presentation, or you'll be able to download it from the archive website later this afternoon. At this time, it's my pleasure to turn this over to Matthew Hamilton and Anders Thulin. Matthew, take it away.
Thanks for the introduction, Billie. Good day, everyone. I am Matthew Hamilton, Business Development Manager for Education Markets with Siemens Smart Infrastructure. And with me today is Anders Thulin, Business Manager for Siemens eMobility portfolio. We're excited to have the opportunity to be speaking with you all today about a topic that I'm sure everyone on this call is either actively involved in planning or will soon be getting questions about from the stakeholders on your campus. We have a great content of some technical detail, lessons learned from universities, forays into EV charging and fleet electrification. But before we get to that, I'd like to take a moment just to root our conversation today in some of the key trends that we're seeing in higher education as it relates to EV. And within the context of higher education, the first and foremost trend is that of climate commitments and campus electrification. Today, there are more than 800 institutions nationally, colleges and universities that have made a concrete date, commitment, and a roadmap plan to achieving carbon neutrality for their campus, with many, many more seeking opportunities to signal their campus's commitment to topics like sustainability and environmental stewardship. Campus electrification, and by extension, fleet electrification, is one of the main levers many universities have when it comes to reducing their carbon emissions. The second key trend isn't just about higher education, but society as a whole. Today, globally, about 1% of the billion or so passenger vehicles on the road are electric vehicles. By the end of the decade, within the United States, it's expected that 1 in 10 vehicles on the road are going to be EVs, and more than 50% of all new vehicles sold are going to be electric. What that means is that there's a growing expectation from the public that there's going to be readily available access to charging infrastructure. University campuses as epicenters of community activity for our local communities, alumni, but also our internal stakeholders, students, faculty, and staff. There's going to be an increasing expectation of access to easy and convenient charging. Also today, more than ever in the past, there's an unprecedented access to funding available to lower the barriers to deploying electric vehicles and by extension, their associated EV charging infrastructure. Whether it be federal funding from the recent bipartisan infrastructure law or state level initiatives all the way down to regional and utility incentives and grant programs, the more funding exists today than there ever has been to accelerate the adoption of EV and to convert and electrify our campuses. Lastly, as we think about ways of, particularly when coupling electrical vehicle charging infrastructure with on-campus generation, either at a central utility plant or solar panels and things along those lines, there's an opportunity to mitigate rising fuel costs and operate our campus fleets, shuttles, and buses in a more efficient and expected budgetary way. And before I go ahead and turn it over to Anders to take us through some of the technical detail and the lessons learned from other universities' installations, I'd like to take one more moment to call out how critical it is to treat electrical vehicle charging on our campuses through a lens of a strategic approach. EV charging is going to be one of the most publicly visible energy assets on our campuses. Yet, EV chargers themselves remain a piece of electrical infrastructure. And like any piece of infrastructure on campus, it operates within the context of a much larger infrastructure system. Treating EV chargers, plans for fleet electrification as an independent silo outside of the context of all of the utility infrastructure on campus will put your campus in a position where there's unexpected costs or opportunities lost to transition to a carbon neutral environment in as efficient and effective a manner as possible. So I'll go ahead and turn it over to Anders to take us through kind of the meat of what we'll be talking here today. Thank you again, everyone, for joining.
Hello, everyone. My name is Anders Tallien. I represent the portion of Siemens that's responsible for the charging infrastructure that Matt just mentioned. I'm going to go through some of the details that Matt highlighted in some more nuance, but I also want to take a step back and just make sure we have a clear definition of what is e-mobility or transportation electrification in the context of infrastructure. What technology feeds that infrastructure, and what therefore does that mean for your contexts? Because if you think about a campus, it certainly doesn't have just a single context when it comes to transportation electrification. So we want to sort of ground some basics first, and then talk about those contexts in lessons learned in a lessons learned approach to be able to explain what are the key considerations for the different environments that you'll have to deal with when it comes to transportation electrification on your campus. We do want to leave space at the end here also for Q&A. We'll receive them through the chat as we go, and I'll address them as we go to the degree that I can. But then, of course, we welcome a lively conversation. So first, what Matt just said, yes, the market's really taking off. I've been in the industry now for about 5 years, and the industry really has started in the past 5 years. Lots of folks have worked on this since way back in the middle of the early 2000s, but then it was basically nothing that existed. Then Tesla came along, and the market really started to take off. But now we've expanded beyond that. You have the Mustang Mach-E, you have the VW vehicles, and you have basically every single vehicle OEM in the market has committed to an electrification path, many of them extremely aggressively by 2030. But it's not just private cars anymore either. As we transition, some of the more targeted places for decarbonization is actually in fleet contexts. That's school buses, where there's some very interesting and useful use cases that make sense for things like returning power from the vehicle back to the grid or to the building. It's also commercial fleets. Amazon made some very big announcements about its electrification plans, as are other fleet operators. And then, of course, the semi-truck market is also moving into an electrification path very quickly as well. And finally, I think especially for the US context, pickup trucks. Obviously, one of the most relevant vehicles, very heavily purchased, the F-150, 1 million vehicles a year, now is moving towards electrification. That product is now released here in about 2 weeks' time. to the open market, and demand is through the roof. Every single one of the vehicle OEMs who has moved to electrification in the past 2 years have had to more than double their original expectations in terms of demand. So a little bit more what that means in the numbers, though, is we do expect both on the electric car side, on the left-hand side, and on electric buses, trucks, and light commercial vehicles, we do expect a greater than 300% growth over the next 4 or 5 years. And every year that we show this type of a chart, we're amazed by how far off we were the following year. Even when we're very aggressive, it simply was not aggressive enough. I think Matt's point about 1% of a billion vehicles on the road are electric, and think about how much that has to grow, since I think the global trend is going to shift us to a majority electric fleet in not too distant of a future. But it's all about context, where those vehicles go and what do those vehicles need. And context matters a lot on the charging infrastructure side, because it really comes down to a couple of variables: how long you're going to be there and how big of a battery pack you have. We'll get into that in a bit more context in a moment. But think about this in a campus context. One vehicle may have more than one area in which it needs to charge. Where that vehicle lives overnight, where it parks during the day while the student is in a classroom, as an example, on the route to the next place to charge quickly for doing something, for just getting a quick top up. So one vehicle may have 3, 4, 5 different charging points that may be relevant for its use. Some of them on campus, some of them not. But that's important to think about, because it's not just a 1-to-1 ratio. You see a 300% growth rate on the vehicle side. That is actually more than a 350% growth rate on the infrastructure side. So a little bit more about what I mean by context. This chart is intended to show on the x-axis a battery size for vehicles, where the classic private vehicle today on the market is about a 75 kilowatt hour battery pack, which is that leftmost column. In the middle column, you start to see these pickup trucks and some lighter duty trucks that are somewhere between the 1 to 200 kilowatt hour range. And kilowatt hour really is the power, what's defined as power or energy inside the vehicle. Power then delivered is in kilowatts. And on the third column is the heavy duty side. That's heavy duty semi trucks. That would be a transit bus that move through your campus. All those fall in that last column. And then the other factor is dwell time, or how long the vehicle is going to be at that particular location before it needs to move. So in the event that you're charging overnight, your typical dwell time is going to be around 8 to 10 hours. In that case, you really don't need a fast charger, and you have a small battery pack. So in the lower left-hand corner, you have then the slowest of the standard sort of electric vehicle charging infrastructure called the L2 or level 2 AC charging. As you shift up though, even if you have a small battery pack, but you only have a very short time to complete a charging session, that's when you run into, for instance, the Tesla supercharger networks, where you really need to be there a short period of time and then move on. And that then is DC fast charging, what's called FC here. FC 50 stands for fast charge 50. And then you go up into 150 kW range and more, as you need to have even less time at that location. And then shifting right, you really start to look at industrial high power solutions to be able to charge very large battery packs in a short period of time. So really, when you think about the question we often get is, we need some chargers, what should we get? Well, what type of vehicle do you have? And how long is that vehicle going to stay put before it needs to move on? Those are the first 2 fundamental questions that you need to ask. And when you put that in a campus context, you run into some interesting and different use cases that may or may not be relevant for your campus. In the lower left-hand corner, if you think about employees and student parking environments, those are typically going to be there for quite some time. And in the event that they are, that really makes most sense for level 2 charging if you intend to deploy charging infrastructure. Why spend the massive capital for a fast charger if the vehicle is going to sit still for many hours? As you shift up, however, if it's a 1-hour class and then folks are intending to leave, you may start to look at a need for a DC fast charger. If your objective as the supplier of this infrastructure is to help the drivers get a quick top up and really achieve a full load on their vehicle before they move on. Shifting over towards the right on the bottom there in the center column, facility operators tend to operate, in our experience, usually anything from obviously a standard sedan type vehicle, but then also sort of lighter duty trucks. Think of F-150 type of truck. In that event, usually those are going to stay put for a longer period of time overnight. So you still have an opportunity for a lighter cost and lighter power intense charger. Shifting up though, you may have shuttle buses on your campuses. In the event of a shuttle bus context, that's a slightly bigger battery pack usually, and maybe you have 8 hours, but you're trying to make sure that you get that full vehicle charged up, or you have multiple vehicles that you need to charge up with the same infrastructure. So there are probably more heavy duty solutions going to be required. And then over on the right-hand side, spanning that entire vertical space is electric transit buses. And I'll get into why they expand along that vertical space a little bit more in detail. Suffice it to say that you have a different set of strategies that are deployed by transit operators, which includes charging overnight and then charging while en route or while picking folks up on the route. So then therefore that of course necessitates a different type of technology in order to feed that demand. So really, there are probably a lot more use cases on your campus context, and we can discuss those ideas. But really, these are the 5 ones that I'd like to discuss in a little bit more detail as we get to that discussion. First, though, to expand a little bit on the technology that you're going to run into, and this is just using the Siemens context, but there's other suppliers in the market as well. In the lower left-hand corner of that diagram that you saw on the previous page really is what's called level 2 charging. This type of charging infrastructure is anywhere from, I believe it's down to 24 kilowatts, 24 amps up through around 80 amps. But the most common amperage range is around 40 amps today, which delivers at 208 or 240 volt, delivers about 9.6 kW to a vehicle. So when you think about the size of the battery, the power that's being delivered to that vehicle, you take then a 75 kilowatt hour battery pack, you divide that by 9.6 kW, and you get about the time that it's going to take to charge that vehicle. So really what we're aiming for, what the industry is aiming for, is that AC chargers, the standard AC charger products on the market, should be able to achieve fully charging a vehicle, a common vehicle on the market in approximately 8 hours or less. In this context, it's also important to note that all of your vehicles, all the electric vehicles are running a DC battery pack on their vehicles. What that means is that there's an inversion that happens from AC to DC in the event that you have an AC charger. So an AC charger, as you see on the furthest left here, is a very low capital investment for the charger itself. And then on board the vehicle, that gets converted into DC power and then delivered directly to the battery pack. That's different from the second column, which is sort of public-facing DC fast charging, or really any DC fast charging for that matter, where there is still AC power going to the infrastructure, but then there is transformation of that AC power into DC power on board. So you expect this to be much more like a large refrigerator type of experience. from a user's perspective. It's very much designed around what you would experience at a gas station. So in this context, there is no transformation that happens on board the vehicle. So you're able to deliver much higher power, much faster to a vehicle in this context. And however, that comes with the downside, of course, it's a far more intensive capital investment. The third and final column is what we'll call fleet DC fast charging. This is not necessarily a private vehicle or private user facing component or product. This is rather for industrial applications. You think transit agencies, or a context where you have a set of facility operators that are operating fairly heavy pieces of equipment, but it's stored overnight and you want to deploy a lot of power to those vehicles at the same time. And furthest to the right in that image, you see pantograph charging, which is basically a grid system that connects with the vehicles and charges that way instead. You only find that on transit vehicles in the United States today. And that really is there in order to drive a much higher level of power to vehicles than you can even get in cables today. So that sort of talks about the technology, the charging technology, but that isn't necessarily the environment that your drivers are going to find themselves interacting with the most. You're going to obviously pull up and you're going to connect a charge point to your vehicle, but then there is a greater degree of participation with the EV charging infrastructure in the digital environment. In the digital environment, you'll find from us and from others that you usually will have, in a fleet context, you will have an owner's front end experience on the left-hand side here. And then you'll also have a driver's front end experience on the right-hand side. And typically on the owner's front end, what you should be able to do is see all of your chargers in a particular environment or multiple environments, and be able to configure whether or not your charging infrastructure is free to use, should be charged to drivers in a certain way, even at a certain time, keeping in mind many of your campuses probably have an off-peak and an on-peak rate that may therefore necessitate or justify a strategy by which you charge drivers differently during the night and during the day. You could also then, of course, configure and add users to that experience and set up transaction lists and understand what your utilization is. So when you go back and report your sustainability metrics, you can really see things like how many CO2 emissions you avoided by deploying charging infrastructure in real time. On the driver's front end, they'll of course be able to, if they go back frequently to the charging infrastructure, be able to download an app as you would expect in today's environment, set up an account, deploy monetary value to that account, and then use a combination of either RFID cards or QR codes on a charger, or even credit card readers to be able to pay for a charging infrastructure. It doesn't have to be paid for either, right? It could just be, for instance, only students are allowed to charge, and they charge free of charge, but they have to then, tap their student ID on as an example. They can also, so if the owner has allowed for that configuration, allow for things like notifications, remote start of a transaction or a charging session, a trip planner for how to get to the charger, or even things like setting up auto payment and then being able to add stations as a favorite, or even then register to hold the charger for you before you get there. A lot of times what we see today is chargers will be deployed in a context, but the customers are a little bit don't necessarily want to go all in, so they deploy a few chargers. That's not enough, and then all of a sudden it distracts from the core purpose because people now have to sort of compete for that charging infrastructure. So to avoid that in a context of a complex with lots of people who should be inside the buildings rather than compete for spots, what you can do is basically configure to allow people to register to hold those spots. The other thing to note is there will be environments where you do want folks to pay, but you don't necessarily want a credit card reader. Credit card reader can be as expensive as a charger itself. And really the experience that most customers have in an EV context is fairly digital. Most of them carry smartphones. So what we've done and what others have done also is where relevant and where most effective, we're deployed QR codes on the chargers, where you can, if you don't have an app, you don't need to download an app. You can just come up, pull up, tap the QR code, opens up a web page. You can transact in that way, and that unlocks the charger and then starts the charging session. Now, going back to the use cases, I mentioned towards the beginning that we have a few applications that are obviously relevant for charging context in your environment. One of them is facility operations. So if you think about the furthest left-hand column here, second, employee and student parking, top-up charging, or charging environments where it needs to move quickly, shuttle buses and transit buses. I'll talk about the use case or the type of experience you should expect there, the technology that fits into that space, and then some main considerations for those specific use cases. And then I'll finish off with a discussion about general recommendations, not just in any specific environment, but regardless of your environment. So first, on facility operations. You should expect, or what we expect and have seen is primarily longer dwell time periods, larger vehicles, but not necessarily super large vehicles, with therefore larger battery packs, but free charging, right? Obviously, you're not going to necessarily charge a facility operator for using their campus vehicle to fulfill their mission. So in that context, a simple level 2 charger may suffice. You maybe don't even need to deploy any kind of networking or complexity around software or anything of that nature. So our recommendation there really is to keep it simple and balance out what makes sense in power and complexity. Focus on making sure you have enough power, but don't necessarily do a lot more than that. Because ultimately what you're trying to do is just enable folks to do their primary job. And what better place to start really than facility operations when it comes to practice what you preach. Deploying charging infrastructure can be very simple for these groups. Getting the vehicles out there, showing that you're electrifying the vehicles with your campus logo on them, I think is a really good signal to folks who are coming to your campus for other reasons. And then employee and student parking in that second row. There you, at least in our experience, it's fairly long dwell time, but potentially paid for charging. And I say potentially paid for and fairly long because the length of the dwell time may of course depend on the configuration of your campus and the classes and what your students are doing. If they're parking their vehicle for the day, going through their day, or if they're driving a vehicle from location to location, that's going to differ. But that doesn't necessarily mean that you should fulfill the mission of filling up their vehicle entirely. That may actually not be logical or needed or cost effective. Really the question is, in this context, having a payment enabled level 2 charger doesn't mean that you need to have payment activated. It just means that you can use that at your disposal if you choose to do so. In some markets, energy is so cheap that you're willing to deploy charging infrastructure for free for your users in order to drive a specific behavior. In other markets, of course, that's entirely untenable just because of the cost of energy. But you have options. You could deploy for free for a sample period of time and then activate a payment system if that becomes relevant, again, in order to drive a certain behavior. And of course, you could have a thing where employees of the campus don't have to be charged, but others do. So that's entirely configurable, again, with that software. But really, the most important things to take away from this market segment is making sure that that user experience is positive, where that's not necessarily as important on the fac ops side, where you're just trying to get the job done. In this environment, user experience is very important, as it is in a top-up environment. And basically, what I mean by that is understanding how you're going to deploy, how you're going to engage with the student body and employees with the charging infrastructure, what your overall strategy, what you're trying to achieve in the digital space just as well as in the physical space. Understanding whether or not you're going to be using RFID cards or campus cards. And then I think also on the physical side, managing things like cables, which are a new experience on campus that, if not done well, could create trip hazards or create a mess. And really, what you should consider is when you're looking at this environment, even if you don't do it, it makes, at scale, it makes a lot of sense, and we'll get into some more general best practices here in a moment. It makes a lot of sense to engage with your strategic planning organizations and with your utilities, thinking about what would happen in terms of power capacity and what we need to do from power capacity and power equipment if 10% of all the vehicles that moved inside our campus were electric, because they will be very soon. So that's something to keep in mind. On then the third row, on a top-up context, you have a shorter dwell time period, quite short, and that's always going to be a revenue-generating experience. If you think about anyone who goes through your campus and just wants a quick top-up, that is going to be potentially very expensive for the campus for a couple of reasons. One, obviously a lot of energy for a short period of time, but then what is called, and some of you probably know this quite well, demand charges. So demand charges are essentially a fee that takes into account your peak demand. So utility always has to accommodate for your max demand that you're seeing at that site. And if you only see that even once in a 15-minute period over a month's time, you've hit your peak demand, and it's very expensive. So the only way that a public-facing DC fast charger makes a lot of sense economically is if the usage is fairly high. So yes, you hit a peak, but you hit it so many times and you're able to get revenue generation from that. So you can offset that peak demand cost. But if you only hit it once, someone uses that high cost charging infrastructure once or twice per month, that doesn't get you close to getting your money back compared to the money that you have to pay the utility for that privilege. So really, in that environment, it's going to be a payment-enabled level 3 charger. How powerful that level 3 charger is really subjective to what you're overall trying to achieve. If it's a 30-minute top-up while they're eating lunch, that's different than 15 minutes and it needs to be fully charged up because it's on a highway route. And obviously those have massive different cost implications, both on the capital expenditure side, but also on the operational side, which primarily is then driven by the cost of energy and that demand charge fee. And again, same considerations is making sure your user experience is clear, making sure your utilization expectations are clear. How much is that asset going to be used? And working with the utility to make sure that you have a good plan in place. There are a few markets where you can do things like get delay of demand charge so that you get demand up, which would then eventually offset the cost of that demand charge when it kicks back in. For shuttle buses, we expect generally longer dwell times, larger batteries, but probably free charging. And that goes also for transit buses. But on shuttle buses and transit buses, you should expect industrial level 3 charging infrastructure to get the job done. You're not necessarily charging folks there. You're trying to achieve their overall core mission of moving folks around inside your campus or through your campus. Here, some of the key lessons learned are a very close collaboration with the vehicle operators, infrastructure and vehicle OEMs. The engagement of the operators and the OEMs, both on the charging side and on the vehicle side, is important to understand what they're trying to achieve for their purposes, and therefore whether or not you can work together to achieve that together. There are some good use cases where a transit operator was operating inside a campus, through a campus, and the campus could participate in the cost of the infrastructure, deploy that infrastructure in their own environment, and also create, a learning experience for students. I'll get into an example of that in a moment. And really figuring out who's going to pay for all this is going to be important because I think there are some good and sort of value sharing that can be done and cost sharing that can be done to generate more support from various grants, rebates, and funding that's available today. And then en route versus in depot. En route charging is essentially topping up the vehicle as it goes with those pantographs that I showed earlier on. And then in depot can be pantographs, but also plug-in charging infrastructure. Typically, the market is moving more towards an in depot environment, but en route makes a lot of sense where there is no opportunity for the vehicle to move through your campus, for an example, as an electric vehicle, unless something that helps it boost its charge is set up to support them. So the question is whether or not you can work with your transit operators that will operate through your campus to help enable or create more viable projects for electric vehicles throughout your system. So a few key lessons learned that span across these different use cases. And those include that the EV transition is a question of if and not when. Generally, what we expect, as Matt pointed out, you will see a fairly aggressive move in the market towards 50% of all vehicles sold in the next 5 to 10 years will be electric. And I can pretty much assure you that I say that now, and it's probably going to be more the next time we have this conversation, just because of the speed of the transition. So when I say minimum 10, 30 later, and 50 with utility, let me explain what that means specifically. 10% of what your plan is, deploy it now in terms of deploying the actual charging infrastructure. Get a feel for what that charging infrastructure is going to mean for your environments and your users. But while you're doing that, usually what's going to happen is you're going to have to deploy equipment upstream from the charging infrastructure. That includes cable and conduit, low voltage gear, and then of course utility engagement. So when it comes to laying and getting ready for charging infrastructure over a fairly short period of time, let's say you transition from a 10% plan to a 50% plan fairly quickly over, call it 5, 10 maximum years, then the rule of the game is never dig twice. The objective should be that you shouldn't have to tear up concrete for something that you want to expand on that you started just a couple years prior. And really laying additional cable conduit for a future state environment is not that cost intensive. It is more about mobilizing the equipment in order to do it the first time. So while you're out there, even if you lay only pipe and wire or only pipe for charging infrastructure in a future use case next to a few chargers, that makes a lot of sense to do rather than just do those 3, 4, 5, 10 chargers. You should also note that depending on where you are, which jurisdiction you're in, there's starting to be local city code that requires this electrification in and around new buildings in terms of % of total parking stalls that need to be EV ready. And EV ready, for the most part, means that it's able to have the necessary power and can deliver a future state charger when it becomes relevant without a significant capital investment. And then in terms of utility engagement, really think about your overall plan and what 50% of that total end state goal is in terms of power demand, and engage your utilities early on, because even if you're not deploying that plan for 5 years, the utility is going to cut you a much better deal and work with you much closer if you're able to provide them a roadmap for where you want to go with your campus. Starting now light, and then they can help and work with you on creating the right transmission distribution lines in order to feed the necessary power for your site in a future state. And they may deploy that now or later, but now they've got visibility into your overall objective and what you plan on doing, which will also then give you better rates. And I think that is sort of to expand on that point, the utility engagement behind the meter is in play. Usually utilities only care about up to the customer meter, but almost throughout the entire US now there is some degree of support from the utilities for work that needs to be done behind the meter in order to take advantage of or build up electrification of transportation. And that's because they see a big, obviously, payback by utilization, another set of assets that are using energy from their grid source. So they're able to look at that and invest appropriately in order to enable that at a faster pace. So utility engagement is really key because they can help you plan. A lot of them have these planning organizations today. They can help you fund a lot of these projects. In many cases, the entire charging infrastructure may be funded by utility. And then, of course, not just utilities, there are lots of other funding sources that are available today and are continuing to be deployed. There's a really good source that I can point to in the lower left-hand corner of this slide, which is a DOE slide or a page where you can type in your state, and then within that state, it will show you all the different funding sources that are available for electrification projects. So if you haven't looked at that, I strongly encourage you to do that to see what you could take advantage of in your state. In terms of power consumption, it is something to be said for, we see sort of two different approaches here. Either people who are not doing enough in terms of planning for the power, or people who are doing way too much for what they're trying to achieve. And there's a balancing act there. You obviously don't want to plan too little. You don't want to just tell your utility, yeah, I need 10% this year, when you know that your plan is 50% in 2 years. Because frankly, transmission distribution organization utilities may take, depending on where you are, a long time to be able to support a large load increase. So engaging early with them and building that future state into your overall power consumption plan is incredibly important. But on the flip side, you don't want to necessarily say, okay, I've got 100 chargers in this building, therefore I need 100 times X of kilowatt deployed into my utility demand, because that's not necessarily the case, right? You may have 100 chargers, but do you really have 100 users right away? Or do all those users come at the same time and use the infrastructure at the same time? And if the answer to either one of those questions is we don't know, or maybe, or probably not, then there's a smarter way of doing it, right? Think about basically sharing the load at the low voltage gear system. So if it takes 5 years for the utility to provide you 100% of that demand, and you want to deploy 100% of those chargers, but it takes them no time at all to deploy 50%, then through that digital experience that I showed you earlier, you can configure things and do smart load management, basically saying when vehicle 1 pulls up, if nothing else is charging, allow it to charge at full capacity. Vehicle 2 pulls up, I only have capacity for 1 vehicle. Let's split the power in half and let both vehicles have 50%. Those things are all very configurable inside the systems that you're going to experience from us and from other players. So please don't think that just because I have X chargers, I need X power. It's much more important to think about how those chargers are going to be used in your context. And then I think another thing to keep in mind is some traps. I think avoid vendor lock-in. If someone tells you this stuff is easy and just do this and here's everything all in, be very sure you know what you're signing up for. There are some sneaky business models in the marketplace that basically force you to go with their system for a future buildup. Strongly recommend that when you look at systems, be it on the equipment side or on the digital side, you're looking at it as an open source environment that can expand with the industry participants that exist, not one player. Otherwise, it becomes very difficult for you to negotiate and expand and really get, you know, a competition driving your solution to the solution that you need. So make sure to avoid that. Ask the right questions about whether or not they can operate with third-party software, whether or not they can integrate with third-party equipment. And then I think the final one I wanted to point out before my time is running out here is networking, right? So is just as important as the electrical. I can't tell you how many times we bumped into environments or scenarios in which someone installs an electric vehicle charger. They put it in the wall, plug it in, and they say, okay, everything's fine now, right? It's like, well, not necessarily. If you're trying to configure this thing to be a payment-enabled system with a specific charge during a specific time of day, and by the way, it can only deploy this much power, and both Jim and George need to see the software and be able to manipulate it, then obviously it's a networked device, not just an electrical piece of device. But oftentimes people neglect that until it's fairly late in the game, or maybe even too late. And in campus environments, airports, etc., where cybersecurity is a real concern, managing those elements and figuring out the right networking strategy well in advance is very important. I'll finish with an example here. You know, we work with, as an example, at the University of Michigan that deployed charging infrastructure. We needed to make sure that charging infrastructure worked not just with ours, but with others as well. And, you know, are able to do a lot with basically a transit-like operator on a campus environment with charging infrastructure, working with third parties. And there's a lot of opportunity out there. And I think this was fairly well funded in terms of support mechanisms as well. The other example, I don't have a page on it. The other example is Guelph in Canada, university there purchased a charger and deployed it actually in its campus environment because it's very close to New Flyer, one of the main electric vehicle bus manufacturers in the environment. And they saw an opportunity to provide charging infrastructure there, both for vehicles that are being operated on campus, but also as an educational source for students who are interested in electrical engineering, mechanical engineering, who see the writing on the wall that this industry is taking off. And there's a huge demand for talent coming out of the universities into these industries. Our organization, as an example, has over 30 open headcount asks out in the market today, but that's the same across the board. There's just massive potential to educate folks, get them interested in this, get them on electric buses, get them familiar with it, excited about it, working with it, and then obviously working within those industries when they come out of the schools. So I think I will leave it there and want to make sure we leave lots of time for Q&A. Thank you.
Thank you, Anders. We have a lot of questions, and just so everyone knows, if we don't get to your question, the question will be sent to our presenters and they will get back to you with an answer. So that being said, our first question is, what experience can you describe for secure sites when real estate is publicly owned and costs cannot be funded by public funding for the initial installation or purchase energy? And he gave a follow-up. It's basically daily charging for privately owned employee vehicles.
Public environment, but can't use public funding to pay for infrastructure. Is that what I'm hearing?
Yes, it is.
That's a tough one. And I say it's a tough one because they're starting to develop some what's called right to charge laws that are starting to expand across the country, which basically mandates that specific environments are not allowed to say you can't do this. If a user wants to deploy charging infrastructure to support their vehicles, the building operators have to allow for it. In terms of if the public environment won't allow for charging infrastructure to be deployed there, then obviously the private environments have to support that. If you got a long dwell time, a good example of this is a multi-unit dwelling building, but there's no charging infrastructure at that building, or there is no parking in that building and people have to park street side. In Europe, there's been good city funding to help with deploying infrastructure, charging infrastructure, sort of at the light post to help with those types of environments. But if the city or the public environment is not supporting electrification, then it sounds like those operators, or those users rather, will probably have to leverage charging infrastructure at other places, which becomes public charging, fast DC charging. So if that's a very prevalent experience that you have, no money for public charging, everybody's parking in public land, there's no opportunity to park in private land, then you have to start looking at deploying DC fast charging. If I was deploying DC fast charging in that environment, that sounds like eureka, because it means that everybody wants to have an EV in a college environment. I'll be deploying a bunch of DC fast charging in the middle of, leasing land and then deploying DC fast charging at that campus.
Okay, thank you. Our next question is, in recent campus implementation, what is the trend for the billing models to accommodate faculty, staff, and students?
Yeah, there are a couple things to consider there. By and large, I find that there is a separation between obviously staff and student body. What's good is charging infrastructure allows for that split. You can provide free charging to employees, and you can deploy charging at a fee to student body. But one trap there for the employee side is if you're deploying free charging to the employees, you're basically providing a value-added service to a certain set of employees and not to a different set of employees. And that may become difficult from a taxation perspective, or from like a employee body perspective that needs to be navigated carefully. Another path has been basically you get a certain amount of credits in a particular period of time to charge in those environments, or you only deploy it in environments where you see a significant uptake in EV charging. But generally, I see a split between people who come to work and commute to the campus versus folks who more often live closer to campus, the student body, and don't necessarily need to charge as much at campus. So there may even be a scenario where it's just employee parking that is deployed for EV charging. And another mechanism for enticing the student body to transition to EV charging rather than deploy chargers is to do things like give them favorable parking. You have your ADA parking stalls, maybe deploying EV parking stalls that don't have charging infrastructure, but then motivate people to go pick up those cars.
Okay, thank you. Are you hearing any sort of the amount of time it's taking to order the electrical vehicles for campuses? I know for a while the chips and all were very hard to get a hold of. What is the time to get new electrical vehicles ordered and in place? Are you hearing anything?
Yeah, it's a mess. Is the short version. I think the good thing is a lot of vehicle OEMs are coming with vehicles out now, so you can get hands on the Volvo XC40 Recharge, the Polestar, the Mustang Mach-E, and more vehicles are coming out to market. Tesla's by and large, are fairly backed up at the moment. I think over a year lead time, or close to a year lead time. But I think the scary thing is if you move up into the vehicle size class, you're going to face even more of that. The F-150 as an example, which is a great vehicle in a fleet management context for campus, I believe, because it both is a larger vehicle battery pack. It's obviously meant for industrial application, or can be used in industrial application. And it uniquely has sort of a feedback to grid capability, feedback to local grid capability. Those vehicles are, oh man, I think they're probably not going to be able to get deliveries for new orders until the end of next year, if not the following year. So all that is happening. The chip shortage that exists today will persist for quite some more time, but that's really not necessarily the biggest driver of delay. The biggest driver of delay is you had a market that just blew up during COVID, the speed at which demand increased. So demand far outstrips supply today, but very quickly supply is catching up.
Okay, thank you. Our next question is, can you clarify the AC versus DC option? How is having that inverter embedded inside beneficial to the customer purchasing this?
Question. All vehicle manufacturers of private vehicles, in fact, I'll go up there so we can flip through and look at it in that context. So here, AC and DC is the question. What's the value difference? Why wouldn't I always do this thing over here? And it really comes down to that all vehicles, private vehicles or private-like vehicles, around 75 kilowatt hours, are built with these inverters on board. And they're built with those inverters on board because the vast majority of use cases, over 80% of all charging, happens at the home. And at the home, there's no capacity to provide 480 volt AC power at these power levels that you see in the DC charging space. And there's really not a real need, right? So the important thing is to balance the charging infrastructure with the use case for that particular vehicle. So if you just need a slow charge, that's fine. Usually when people look at the AC charger and think, oh man, 8 hours to charge the car, but then they ask me, well, how long does it take you to charge a car using AC power? And I say about 3 seconds, because I plug it in and then I go inside and I watch Netflix, right? So it's not like your experience at the charger is a long period of time, because it's going to be charging when you don't need it. And by the way, charging off peak when you're sleeping is the best time to charge, because that's also when the energy is cheapest. So all vehicle OEMs know this. That's how they design the systems. And that then therefore means that the conversion transformation doesn't have to happen in the charger. So the charger itself can be fairly cheap. This charger, as an example, is almost 1/25th the cost of a public DC fast charger. So just the capital investment itself sort of pushes you whenever you can towards that AC approach. As you shift into heavier duty vehicles, they just skip those inverters altogether because they know there's no use case where they're allowing for 40 hours to charge a vehicle using AC power. So they don't have inverters, they have to do DC charging. So those are the key things that drive the differences between the two.
Okay, thank you. Our next question is, if electrical vehicles expand quickly, do you foresee a problem with utility providers keeping up with demand?
Very good question, hotly debated topic. And I think this is maybe slightly controversial, but I'm going to say generally no. And the reason for that is I did a model recently for a city where we said if a third of the city electrifies its vehicles, its privately owned vehicles, and everyone charges sometime between, call it 8 a.m. and 4 p.m., peak demand time, both at the 8 a.m. range and at the 4 p.m. range. And then there's a dip in the middle of the day, but generally during the day. You would have to deploy a new nuclear power generating capacity facility of a significant magnitude. But if those same 30% were to charge their vehicles at night between 9 p.m. and 6 a.m., no new capacity at all would need to be built. And that's because, by and large, there's a massive difference between what the US grid has in terms of its total peak demand capability and what the demand looks like at night. And that's because everyone's running their, their dishwasher and their laundry at 8 p.m. When they come home from work. Everyone's using all their stuff, their heating and everything else in the morning before they leave for work. So you see these massive peaks that the system has to be ready for, and then very little usage during the night. So there's a ton of demand capacity to be able to take advantage of really what grid operators and power system operators and frankly you all could do to help further that and make the life of grid operators easier and deploy your projects more quickly is to create the right set of sticks and carrots to drive a behavior of charging off peak. That's going to help both climate from a climate perspective, because driving peaker power plants is a pretty dirty engagement. And it's going to help with offsetting costs for your drivers and the cost to the utility. There is good argument that the increase of EV is actually not going to increase rates from utilities. It's actually going to decrease them. Most of the major, or all the IOUs, large utility players, public utility players, have a formula that if demand goes to a certain level, either they have to invest that in infrastructure to meet that demand, or they have to cut their rates because there's not an increasing demand for infrastructure to supply because there's not to match the demand. So what's beautiful with EV charging is you're charging during the night, ideally, and when doing so, you can basically cut down on the infrastructure needed. I don't need new infrastructure, but I do have a lot more demand. That means I, as a utility, make a lot more money. I have to disperse that by lowering my rates to my ratepayers. So all of a sudden, rates actually could go down across the user base.
Okay, well, thank you. Well, we have a lot more questions, but we are out of time. So I want to thank Siemens and for Anders and Matthew in particular for doing this presentation. As always, thank you very much. And to our attendees, thank you for taking time out of your busy schedule to be with us today. So until next time, be safe, stay healthy, and be kind to one another. Thank you so much.